Hello everyone. As we are busy for the next week before the quiz 2, we're not planning to have a tutorial, so I'm recording the solution to the last year quiz problems and also some of the topics related to the demand forecasting that we have discussed. This quiz will have topics related to demand forecasting, the supply chain management module that we have covered, as well as the theory of constraints that we are going to cover tomorrow as part of the goal movie, right? We'll just briefly refresh some of the topics related to demand forecasting, and then we will go and solve the problems which were there in quiz 2, which were related to the topics that we have covered. All right. Okay, here we go. So to start with, demand forecasting, we had discussed about concepts related to what is trend, what is seasonality, what is cyclicity. There was a video that I had shared with you earlier. You can look at that. All data which is related to time series generally has elements which are related to either trend or seasonality or cyclicity, cyclical patterns, or all of them together, right? Now, the way trend works is that trend is basically something that is increasing with time or decreasing with time on average, right? Please remember that word on average, because not saying that something is completely increasing with time or something is completely decreasing with time. So trend is something that is on average increasing with time or decreasing with time. So if you look at how an increasing trend looks like, so if this is the, okay, let me redraw this particular thing. So if I take, okay, so if I take X and Y axis, and if I'm saying that there is an increasing trend, let's say this is my demand, and this is over time, if I want to look at it, then an increasing trend would probably look something like this. And a decreasing trend would be something which goes like this, right? As you can see over here, it is not something that is increasing every single period, but on average, if you actually look at it, it increases with time. So this is how a trend line, if you are fitting to this particular data, would look like. We have done this particular thing in Excel. You can also try that with every chart that you have. You can always fit a trend line, and this is what it means, right? And for an increasing trend, you always have a positive slope. That is, if you write the equation of this, dt will be equal to, let's say, b0 plus b1t, where b1 is the intercept and, sorry, b1 is the slope and b0 is the intercept. B1 will always be positive, right? For an increasing trend, it will be positive. And for a decreasing trend, this will be negative, right? So this is the concept. Now, the same way, if you're fitting a line for this negative slope or decreasing trend, this is how it will look like, and it will be a downward sloping curve, right? So that is what this particular thing is. So whenever you are trying to use regression to identify the trend component, this is how it look like. Okay. Now, next comes the seasonality component. Now, what does seasonality represent? Seasonality, as we have discussed, is anything that repeats with time, right? Now, with seasonality, there is this concept called periodicity. Periodicity tells you after how many time periods is this pattern repeating. If, let's say, for example, in data, you've collected data for multiple quarters, and you have a hunch that the demand pattern repeats after every 4 quarters, right? So the periodicity happens to be 4 over there. Or if you've collected data for every single day of the week and for multiple days, and you see that there is a pattern that is repeating after every 7 days, then the periodicity happens to be 7 over there. Now, with the Marret-Rooms forecasting case that we have discussed, there the data was given for every single day, and we have assumed that this particular pattern repeats after every 7 days. So we have done all our analysis for Saturday that indicates some kind of seasonality which is there. We could have also assumed that the periodicity there is 2, that there is either weekdays or weekends, and the pattern kind of is replicated either on weekdays or weekends based upon the downtown hotel properties that are there, right? So either way works, but depending upon what you think is the pattern that is repeating, you would apply there to understand the seasonality, right? Usually this is how a seasonal pattern looks like. So if I am trying to showcase that, so if this is my X and Y axis, and let's say, for example, this is on Y axis, I have dt, and this time over time. So some kind of, so let's say a wavy pattern is something that you'd see, right? So if let's say this is period 1, this is period 2, let's say this is period 3, and this is period, so let's say this is period 4, you can see that there is some kind of pattern that is repeating after every let's say 4 periods or 2 periods, right? So you could see that there is some kind of a pattern that is repeating. So this wavy pattern or some kind of a spikes and troughs kind of a pattern is something that you would see in seasonality. And there is some kind of an increasing or a decreasing trend that you would see in the trend concept. Cyclical pattern is something that is not relevant directly to us. It is usually used by economists to study business cycles, where we are talking about recessions or booms in general in the economy, right? So that's something that is not relevant for us. All right. So when we discussed about demand forecasting, we talked about things like, we said that there are largely 2 ways of doing forecast. One is a qualitative forecast. The other one is a quantitative forecast. We said that we'll be focusing on quantitative forecasts in our course. Under quantitative forecast, we said that there are 2 types of forecast that we are interested in. One is a time series forecast, and the other one is a regression-based forecast. Right? Now, under the time series forecast, we said that there are multiple different types that we studied. We started with a very, very basic approach, what we call as a naive approach, where we said that the forecast is nothing but, the forecast for tomorrow is nothing but the previous value, right? Previous value that is available to us. On the other hand, we said that while this approach, as the name suggests, is very, very naive, we said that the other better methods that we have is we use the past data and identify an average. Now, this average is not just a fixed average value, because we are taking average of the previous few values starting from that particular date. We call this as a moving average. Now, there are 2 types of moving average, one which is called as a simple moving average. The other one is a weighted moving average, right? Now, a simple moving average is where you're taking the past few values and simply calculating the average with equal weightage to everything, right? It's a mere average or a mean of the previous few values. Now, how many previous few values? As we have discussed, it is something that is up to you to identify. Then under weighted moving average, you are going to take, again, the discretion of identifying how many previous values is up to you. But here, you add weights to that particular thing. Now, there are 2 ways to do this weighted moving average. One is where we take a positive integer weights to that particular thing, positive or non-negative, it would be 0 as well, and just create a weighted average. Or as your textbooks points out, you can take weights which are between 0 and 1, such that the weights of all the values that you assign weights to happens to be equal to 1. I'll explain that in a moment. Then the third one, which we said is the exponential smoothing. Exponential smoothing method is where this particular method we had discussed that the benefit of exponential smoothing is that it provides you with using only one particular constant, a smoothing constant. It kind of gives you a benefit of replicating whether it is a naive approach or a simple moving average or a weighted moving average, right? So that's the benefit. Now, in regression, we said that this is something that you've studied in business statistics as well. It's a concept where we are trying to find a linear relationship between a dependent variable and a set of independent variables, right? Now, the focus in regression is to try to identify whether certain set of variables are significant or not. And we said that the way we will identify that is by comparing the p-value of the output with an alpha value that we choose. Generally, we choose the alpha value to be equal to 0.05, and that's a common value that you can choose. If you are using other alpha values, you can always compare that with that. Okay. Now, let me just spend some time trying to showcase about this weighted moving average and exponential smoothing, just a little more than what we have discussed. Simple moving average and naive approach, you can refer to the slides or the discussion that we have had earlier. Now, in weighted moving average, so I'm representing moving average as MA. We said that the forecast for the future is nothing but Wt dt plus Wt minus 1 dt minus 1 plus and so on divided by Wt plus Wt minus 1 plus and so on. Now here, this is the difference between what we have discussed in the class and what is there in your textbook. Both are more or less the same, but just for you to understand how they both converge to the same thing, I'm explaining this. Now, if you look at this, so here, if you look at the weight that is associated with dt, one can say that the weight associated with the demand value dt is Wt, or I can also write it like this. Yes, Wt divided by Wt plus Wt minus 1 plus Wt minus 2 and so on. Take this as 1 unit and multiply with dt. Same way, Wt minus 1 divided by Wt plus Wt minus 1 plus Wt minus 2 and so on, dt minus 1 and so on. Now, this particular thing that we have over here can also be considered as one particular weight, and this particular thing also can be considered as a weight for dt minus 1. The good, beautiful part of this particular thing is that if you add all the weights, the sum of all the weights that we have over here, these weights, if you sum for all the values that we take, this will turn out to be equal to 1. Now, whether you take it this way or the way that is mentioned in your textbook, where you say that the weights, where in your textbook, this is written as Ft plus 1 is equal to Wt dt plus Wt minus 1 dt minus 1, Wt minus 2 dt minus 2, and so on, where the sum of all weights, right? Sum of all weights, let's say I is equal to 1 to t, happens to be equal to 1. Now, this is nothing but equal to the concept that I've mentioned over here. Both are exactly the same. Right. So this is the weighted moving average. Now, in exponential smoothing, we have discussed this in the class as well, and where we said that the exponential smoothing kind of converges to your concept of exponential smoothing converges to the concept of your naive approach or a weighted moving average or a simple moving average just by changing the values of alpha. Now, as you know, in weighted moving average, you will have to choose multiple different weights depending upon the size of data. It might be a big cumbersome issue to calculate all the different weights, right? The good part with exponential smoothing is there is only one smoothing constant that you have to choose. And this particular smoothing constant happens to be between 0 and 1, right? That is the concept. We said that Ft plus 1, which is a future forecast for the demand, happens to be alpha into dt plus 1 minus alpha Ft, right? This is the formula that we had given. Now, over here, if you choose an alpha value equal to 1, this particular thing entirely converts into a naive forecast, right? Now, we said that this is a recursive formula. That means Ft in this particular case can also be written as alpha dt minus 1 plus 1 minus alpha ft minus 1. And the same way, ft minus 1 can also be written as alpha dt minus 2, 1 minus alpha ft minus 2, and so on. Right? So you can continue this particular thing again and again. Now, if I substitute this value over here and this value over here, the equation ft plus 1 would become, this is the longer formula that we have discussed in class, alpha dt plus alpha into 1 minus alpha dt minus 1 plus alpha into 1 minus alpha square dt minus 2, and so on, right? So it's prudent to also remember this particular thing, because this is almost equivalent to your weighted moving average, where all these weights are nothing but the weights corresponding to that. So this is basically the concept of exponential smoothing and your weighted moving average, right? So for the rest of the things, you can either refer to the slides or the textbook. Now, to identify the efficacy of any particular forecast, we said that we have three major metrics. One is your mean absolute deviation, then you have mean squared error, and mean absolute percentage error. Mean absolute deviation is nothing but an average of the absolute deviation, right? Absolute deviation. Now, how do you calculate absolute deviation? Absolute deviation is the mod, or just the magnitude of the difference between the actual value and the forecast, right? Now, you calculate this for all the different values and you take an average of that, right? That is the mean absolute deviation. On the other hand, mean squared error is the average of dt minus ft whole square. Now, we said that whether we take the mod value, the absolute value, or the square, if there is a positive value, negative value, it just gets cancelled out, because an absolute value will remove the sign from that. The same way, a square will also remove the same thing, right? These two values, mean absolute deviation and mean squared error, are kind of sensitive to the kind of units that you choose. Let's say, for example, you do this mean absolute deviation calculation for somebody is trying to predict the temperature in centigrade, and somebody is trying to predict the temperature in, let's say, degrees Kelvin or degrees Fahrenheit. Your mean absolute deviations for two people who have predicted the exact same values in two different measurement systems will be exactly different. So that is going to be a problem. Now, for those reasons, to avoid the issues related to what measurement metric you choose, I'm going to choose this mean absolute percentage error. At the end of the day, when you're calculating percentages, it doesn't matter whether you are calculating your overall currency in dollars or rupees, or if you are calculating your temperature in degrees centigrade, Kelvin, or Fahrenheit. So everything remains the same. So that's the reason why what we do is we calculate the average here in terms of, so this is the absolute error, divide that by your actual demand value, and then you take the average for all the values that you've calculated. So this is the mean absolute percentage error, right? Now, ideally, we would want these values to be as low as possible, right? And we try to compare different metrics based upon whichever metric happens to have the lowest MAPE value. That is how we calculate this, right? So this is generally this, and the error or deviation value, we said error slash deviation value, we said we can calculate as dt minus ft. So this is something that we have discussed. So this is about the overall theory part for the forecasting, demand forecasting part. What we will do is we'll look at some of the questions. I think there are only 4 or 5 questions which were there in the quiz, which are relevant to the syllabus that we have covered. So I'm going to look at that and explain how we calculated those things. So you can refer to this video if you are trying to look at the how to solve this particular thing. All right. Okay.